Alright guys, welcome back to Walden's World. Today we're going to be making quite a long video. I will have all the products to fix any of these problems in the description with links either to eBay or Amazon. I'll try and find the cheapest stuff for you that will work for these scooters. They're Chinese. So this is going to be what we'll call the top 5, 10, 15, 20, 25, 20, 15, 10, 5 reasons why your scooter ain't running right. Can either be it ain't starting up, won't go down the road, don't move, won't turn over, whatever. We're going to go through all these problems. I've got a couple of scooters I got to build for the mall, so we're going to get those done, and one of them actually needs a motor. Understand one thing with vehicles, you've got to always have 3 things in order to get a motor to turn over, and you've got to have oxygen, you've got to have fuel, and you've got to have a spark. So if you don't have all those, you can't get a fire. Now to get something to explode, you got to have it in a sealed container. So if your piston and all that ain't sealed and you've got air leaks, ring gaps, or whatever, valve problems, and the air can escape, you're creating a fire and not really an explosion. So we'll go over all that, and hopefully this can help you out. But anyway, number 1, like the video. Subscribe if you got an account, or get an account and subscribe, and share it. You know, anybody's got a Chinese scooter, we're going to go over every single problem that you can have, basically, literally how to build a basic new motor and, you know, new scooter. So here we go. Alright, so the first thing we're going to check is we're going to check some electronics. So if your scooter don't turn over or start, or you don't hear it clicking or anything like that, first thing we need to do is number 1, or if your lights don't come on, all that stuff. You need to check your switch. Some of these, the backs pop out of them, or they get water on them down there and they go bad. So this is the actual plug-in for the key switch. Definitely all of them are going to be at least 4 wires. This one happens to be 5 wires. So on these, we won't use the term hot wire. We call it bypass. So if you ever had to bypass your key switch because it was bad, your red wire is always 12 volts. That comes right from your battery. It has 12 volts right now as long as your battery's good. Once you turn your key on, you then have 12 volts that goes to your solid black wire. Now your solid black wire is going to feed most of your electronics throughout your scooter that need to be turned on only after the key. So when you go to turn your bike off, your spark is this black and white wire, and it gets grounded out to the frame, and that's how your motor stops, turns everything off. So to test this, there's a couple of different ways. If you have a test light, first thing you do is ground out your test light with a clip. Then you check your red wire. Of course, this would need to be clipped into your wire harness. As long as your test light comes on, you're good. So on mine, they actually cut this wire harness, so I'm going to have to do it a different way. You can take a voltmeter and put it to your ohm setting. A lot of times if you put to the smallest ohms, you have I think you do. You got a beeper on a lot of these. Either way, once you have a solid connection, this usually should go out to about 0 or close to it. The longer your resistance is, the bigger your number gets in the decimal range. So the simple way to check our light switch, we can actually just take, and if you got a voltmeter, so my key's on, turn it off, goes to 0, turn it on, beeps, plus I see my resistance. You can do that the same way with your kill switch. So, kill switch. Right. Turn the bike on, kill switch is off. Turn it back to kill, and it works. And both these green wires are actually connected together. So I'm not sure what that is. It's something else later on in the system. Okay, so we know our key switch works. And for right now, we just bypassed ours. I just tied the black and the red together. So I know I've got electricity through my key switch, and now I can check and see if I've got any more. Now the first thing we can do is we can hit our brakes, and our brake light should come on if we've still got power. Okay, so this is our culprit here. We didn't have this one hooked up and this cable's fried. So our tail light was actually already on. If you see here, the brake light. Next thing we want to do is check our brake lights, make sure they work. If they don't work, this don't send electric voltage to my start button, because it comes through here first and then it goes to your start button. So after that, once you got voltage comes through your brake, or I call it a dead man switch, your power goes to your start button, and that's when you can actually hit the start button. So our brake light works, our dead man switch works. Let's say it didn't work. We didn't know if it did or not. So let's find out what's going on with it. Let's do this, and let's see here. We'll get our test light, and we want to ground it to a good ground. So mine's long enough, I can do it to the engine, and we'll check for power here. So we've got power there. Let's make sure it's off. We don't have any power, but like I said earlier, our black wire is always our positive. We got a black wire here, so that's positive. If we can get our probe in there. Oh, lost my lead. Okay, so that's positive. And that would be positive if our brake switch worked, which it does. We pull on the brakes, it works. You can do that with the beep test too. You just do your beeper across both of them. So now we know we've got power going through our yellow and green. Our yellow and green comes up here to the starter button inside this harness. So you have to have your brake on, you hit your button, and that's when we actually hear that clicking. So if we didn't hear that clicking, how do we test that start button? Let's find out about that one. We know the yellow and green wire. Holy crap. We know the yellow and green comes to the starter button, so that's our positive juice to the starter. Let's see where the wire harness is. Right here. Okay. They may have changed colors on us. They sure did. Yellow and green is now. Let's figure out what's going on in the kitchen. I guess it's this yellow and red one. Okay, so I messed up earlier. I have to retell you this differently. This green and yellow goes down to your starter solenoid. So this is positive, goes to your starter solenoid, comes back up to this yellow and red here. So we've got power, goes through the solenoid, comes all the way back up here. Once it hits here, it grounds out. And when it grounds out, that's when it turns over. And that's what you hear. So this is grounding out. I could take this and stick it to a ground and hit that and show you that that's how it works, but there's really not much point in it. I would have to hook this up to the other end. But anyway, so if you need to check this, you could take and let's unhook it for a second. If we can. Sweet Jesus. Please, Chinese plastic clip, go back together later. I don't know that I can get the pin in there. Maybe I can. I'm going to rest it right up against that green one. Oh, I need my voltmeter. What am I doing? Okay, so we want to test the yellow and the ground. Yellow and red and the ground. Should be able to hit the button. And we got our beep. So that's how you check your starter button. Alright, so let's say your tail light comes on, your brakes work, your key works, your horn works. Okay, so we know we got electronics to the scooter, but we didn't hear that click a minute ago. So let's say we didn't hear that. How can we test that out? So we've got our starter solenoid here, and depending on your scooters, depending on where that's at, and these are our wires. So if you remember correctly, which these are actually switched, But originally this one is our hot, which is hot right now because our brake light is on. If we turn this brake off, we should lose power to it. So my brake lever's broke, whatever. Power's on. What we don't have power to is through here. Oh wait, we do have power here because it comes through here, but it's not grounded out, and so therefore it don't work. So one thing we know for sure is if we don't have power through this right now, then we have a problem inside the solenoid. Now, so on this, we've always got 12 volts to the red. All right. And we've checked that. We know that when we hit our button, everything got that grounded out and all that. But we do not have 12 volts to this side. So if you take your test light, you can use a voltmeter too, and you hit your start button, you should get voltage. So if you know you have voltage coming through your yellow and green and your red and yellow, but you don't hear any click, and we've checked all the other stuff, then we know we got a bad solenoid. All right. So one other way is you can just put a deal on here. That goes to the starter. All right. So we've checked all that. We've got voltage to there, and our thing won't start. More than likely, it's your starter. Let me see if I've got a starter laying around here. All right. So this is going to be a primitive starter test. This is just my starter wire. The motor itself always grounds out to the frame, so as long as your motor's in the motor, then in the engine, shall we say, then it should work. So we'll just pop this right quick and see if this thing will jerk. So we know that works. Another way you can test it, once again, now if you did that and your motor didn't work, then obviously you know something's wrong. But there you go. Alright, so I think this starter actually fits in this bike. This one don't have it. We're going to be using this motor on something. Anyway, so that's the electronics. We'll deal with the charging system on another video that'll deal with spark. Anyway, so like I said, like, subscribe, hit the notification button, but that's just the starting system itself. So there you go.